So this next section, we're going to be talking about parallel and perpendicular lines. They're going to give you a problem where they give you a line, either on a graph, or they'll give you like 2 points on the line, and they'll ask you what's the equation of a line that's either parallel or perpendicular. So go ahead and pause your video and write this stuff down. So everything I have down here, write this down in your composition book. So pause the video. All right, so everybody has written it down. It's unpaused. So let me go through these here. So parallel lines. These are two coplanar lines, and they are parallel if and only if they never intersect. So remember, coplanar means that two lines are in the same plane. Like, okay, I've got three lines right here. These are in the same plane. These are coplanar lines. And also remember, if and only if, that's the biconditional. That means if this is true, this must be true. And if this is true, this must be true. So in other words, I could say that if lines are parallel, then they never intersect. Or I could also say it as if two lines never intersect, then they are parallel. All right? That's the biconditional. That's what if and only if means. Now we also have perpendicular lines. Two coplanar lines are perpendicular if and only if they intersect at a right angle. So in other words, a right angle, that is 90 degrees, right? 90 degrees. So they have to intersect at 90 degrees. Parallel lines are parallel. They never intersect, right? Parallel lines are like this. Those are parallel lines. All right, so let's look at an example of a problem here. So I wrote a graph, I got a line, and I also have this third point out here, and we're going to do something with this later. So make sure you have that point down. Now, the first thing we have to know is how do you make an equation from a line? If you're given a line either as a picture or as coordinate points, how do you make an equation of that line? Now, some of you hopefully remember this from algebra. So the first thing I want to do is make an equation from a line. So you remember that it's always y equals mx plus b. Not going to get too fancy with standard form. Just slope-intercept form is good for us. So y equals mx plus b. Now that means I need to find an m, which is my slope, and I need to find a b, which is my y-intercept. So those are two numbers that I need to find in order to get an equation for this line. So let's start with the slope. Always start with the slope first. So I have a slope here. The slope is m. So m equals y2 minus y1 over x2 minus x1. Now, in order to plug something in, I need to find some points here. So let's look at this point. This point would be at, let's see, my x is 2. So I have 2 comma 1, 2, 3. So y is at 3. All right, this point over here, well, let's see, x is at negative 1. Y is up at positive 1. And then my third little point out here, I don't need it, so I'm not going to worry about it quite just yet, but we will later. So now let's start plugging some stuff in here. So I'm going to say, let's say this is the second point, this is the first point. So my x2 and y2 are over here, x1 and y1 are over here. So I'm going to have y2 minus y1, so that's 3 minus 1 on top. Then on the bottom, I'm going to have 2 minus negative 1. Okay, good. So 3 minus 1 is 2. 2 minus a negative 1. Well, I got these two negatives right next to each other, so it becomes plus. So I'm going to have 2 plus 1. 2 plus 1 is 3. So my slope is 2/3. Now, another way you could do it, since I have a graph, you could just do rise over run. This is a rise of 1, 2. It has a run of 1, 2, 3. So that would be 2 over 3, which is exactly what I got. But you need to know how to do it this way, because on the test and on the CBA, A lot of the questions are just going to give you these little not endpoints, but they're going to give you 2 points on the line. And that's all they're going to give you. They're not going to give you a pretty picture. So you need to be able to work with just the points alone. So we got the slope. So I know M. Now I have to find B. So let's see here. What is B? Well, let's think about this. I know what M is. I can plug in a Y and an X and then solve for B. If I pick one of these points, I could pick either point. And I can just plug a point in for Y and X, and then I can get it that way. So what I could do here, let's just use this point right here. Let's use the second point. So in this case, Y is going to be 3. So I'm going to have 3 equals M, I already know, that's 2/3. Let's see, what's our X? Well, let me look at this point. My X is going to be 2. And then finally, plus B. And I just have to write B. I can't plug anything for B because I have no idea what it is. I know an X, I know a Y, I know an M, but I don't know a B. All right, so let's solve this out here. So this becomes 3 equals, let's see, that would be 4/3 plus B. So now I just subtract. So I'm going to have, let's see, subtract 4/3 so I can get B by itself. So 3 minus 4/3 is going to equal B. Now let's think about this here. I got to subtract these. I need a common denominator. So how about we do 9/3? How about 9/3? Because I know that 9/3 equals 3. So 9/3 equals 3. So 4/3 I don't have to mess with. And 9 minus 4 is 5. And we keep the 3. I don't know why I started drawing a 5. So we get 5/3. So that equals B. So B equals 5/3. And you can always use your calculator too. You can just use NSOLVE if you want. I'm fine with that. So B equals 5/3. That means that my final product here is Y equals, I know my slope is 2/3. 2/3 X plus, and my B was 5/3. And if you want to write this as 1 2/3, that's fine. I just prefer to keep them as fractions. It just makes it easier. Honestly, even though they're improper fractions, it's still, I prefer it like this. It just makes it easier to work with. So that's how you find the equation of a line with 2 points, right? Equation of a line with 2 points. Remember these steps that I just did. If you don't understand it, watch it again. If you still don't understand it, ask a question, because we're going to be doing this again and again and again. All right, you're going to be seeing this over and over and over.